Hi everyone, I am Dr. G. Swapna, Assistant Professor in the Department of Mathematics, VNR VJIT. In this lecture, we are going to start the solutions of partial differential equations. Here we have different types of solutions are there. So one is a complete solution, general solution, and particular solutions. So if the solution of first order differential equation which contains two arbitrary constants is called the complete solution. If suppose a solution obtained from the complete solution by assigning a particular values to the arbitrary constants is called particular solutions. The solution of partial differential equation which contains arbitrary functions is called general solution or general integral. Here for finding the solutions of partial differential equations we have different types of there. Here we are going to discuss one of the type, that's a direct integration. So here just I will explain through an example. If we observe the equation, if we observe this problem, dou square z by dou y dou x plus 18xy square plus sine of 2x minus y. In all the terms, only one of the term having a derivative. In all these terms, only one of the term having the derivative, the remaining all are the functions of x and y. For such type of equations, we can evaluate just by direct integration. Here observe the given equation having the term derivative with respect to y and also x. So we need to integrate directly with respect to these independent variables. In any order you can integrate, because in partial derivatives we have dou square z by dou y dou x is same as dou square z by dou x dou y. Because of this property, we can integrate with respect to x first and then y, or vice versa. Integrate with respect to y by keeping x a constant here, integrating on both sides with respect to y by keeping x as a constant. So integral of dou square z by dou y dou x plus integral of 18xy square with respect to y plus integral of sine of 2x minus y with respect to y is equals to integral of 0 dy. Now here integration and derivative both are inverse functions. This integral, this derivative with respect to y and integration both gets cancelled. You will get it as dou z by dou x plus, here we differentiate with respect to, we integrate with respect to y by taking x as a constant. 18x into integral of y square by cube by 3 plus integral of sine is minus cos of 2x minus y here by y coefficient, that is minus 1, is equals to integrating constant. In general we are adding an integrating constant as c, but here we are adding integrating constant as function of the constant variable. Here we take x as a constant, so we take it as f1 of x as an integrating constant. Because x is constant, function of x is also a constant. That's why we are adding f1 function of x, that's f1 of x, in place of an arbitrary constant. That is nothing but arbitrary function. Now again integrate with respect to x by keeping y constant. Now integral of dou z by dou x plus integral of 6x by cube, minus of minus becomes plus, integral of cos of 2x minus y is equals to f1 of x integral with respect to x. Integral derivative again gets cancelled. You will get it as z plus. Here we integrate with respect to x by keeping y as a constant. So 6y square y cube constant. Integral of x is x square by 2 plus integral of cos is sine of 2x minus y by x coefficient, that is 2, is equals to integral of f1 of x dx plus, again we are adding an arbitrary function as a integrating constant. What is that arbitrary function here? Here y is constant, so we are adding here function of y. So just simplify this. This is the required solution. That's it. This is applicable only when the in the given equation, if it is having the term is one term is having in terms of derivatives and other all the functions of x and y, then we are integrating. Directly use the direct integration method. This is not possible in all the cases. So if we take another example, if Lagrange's linear equation, it has some particular form of the partial differential equation. So here a linear partial differential equation of first order, particularly a linear differential equation. Linear means each variable is of degree 1 and the partial derivatives of first order, then it is called the linear partial differential equation of first order, is known as a Lagrange's linear equation, which is particularly of the form pp plus qq is equals to r, where p, q and r are the functions of independent variables, that is x and y. So how to solve this? For solving such type of Lagrange's linear partial differential equations, just by writing the subsidiary equations, dx by p is equals to dy by q is equals to dz by r. To solve these simultaneous equations and then find the two solutions, u is equals to a and p is equals to b, either by considering solving any two fractions. Here we have the three methods. We can choose in different fractions. If we choose 1 and 2, if we take 1, 2, 3, if we can take 1 and 2, that's as a one equation we will get, and we will or 2 and 3 or 3 and 1. We have three possibilities are there. In those three possibilities, either we will solve, if it possible, you can solve any of the two sets of solutions. You will get the two sets of solutions by solving the two equations. Or if it not possible, then you can use the method of multiplies. But in any of these two ways, you need to find out the two solutions. One is, we let it be considered as u is equals to a, and the other is considered as v is equals to b. Then the complete solution can be represented as v is equals to f of u, or u is equals to f of v, or you can represent f of u comma v is equals to 0. In any of these ways you can use to represent the complete solution. So I will explain through an example. We will consider this. Just observe. Solve y squared z by x into p plus xz q is equals to y square. Is it directly in the form of pp plus qq is equals to r? Yes. But you can hear fraction is there. Just simplify this equation first. Y square zp plus x square zq is equals to y square x. Now observe, it is in the form pp plus qq is equals to r. This small p and small q r indicates that partial derivatives. As you know that p is dou z by dou x, q is dou z by dou y. That is a first order partial derivatives. and capital P, Q, R are the functions of x, y. Here observe that PP plus QQ is equals to R, exactly in the same form. So which is called it as Lagrange's linear differential equation. Now step number 1, find the subsidiary equations. Just comparing and write the values of P, Q and R. dx by P is equals to dy by Q is equals to dz by R. Now just replace PQR values here. Dx by y square z is equals to dy by x square z is equals to dz by y square x. Okay, here these are the subsidiary equations. Our task is to find the two solutions. One as u is equals to a and the another one is v is equals to b. To find out those, either we can use solving the fractions, any of the two fractions, or method of multipliers. Here first we need to check it, either of fraction method is possible or not. Suppose if I am taking these two fractions, let us explain with this. Dx by y square z is equals to dy by x square z. Here observe, here these are the differential coefficients are y and z. So the remaining variables are also keep it in terms of x and y only. Observe, is it possible to eliminate the z from this equation or not? Just eliminate this and express this equation in terms of x and y only. X square dx is equals to y square dy. Now you can directly find the solution just by integrating on both sides, because it's separate the variables now. Just integrate. Integral of x square is x cube by 3. Integral of y square is y cube by 3 plus integrating constant sum a. So let it be considered u is equals to x cube by 3 minus y cube by 3. Let it be considered this one as a. This is our one solution. Now we need to find the one more solution like this by considering another fraction. That is also only in the two variables which are in the differential coefficients. If we check it, these two variables y and z, that means x need to be eliminated. Is it possible? No. So take the another value. Take another way. See here, observe the first one, dx by y square z. Dx by y square z is equals to, consider the first and the third one, dz by y square x. Here the differential coefficients are in terms of x and z. Is it possible to y is eliminating or not? Yes, we can eliminate y. And we can express as x dx is equals to z dz. So it is a possible. So you can find out the two solutions by the fraction method, by choosing any of the two fractions from the subsidiary equations. Just by integrating on both sides, then you will get it. X square by 2 is equals to z square by 2 plus integrating constant b. Therefore, let us consider v is equals to x square by 2 minus z square by 2 is equals to b. So therefore, how can you express the solution? These are the two independent solutions. Now we need to write the complete solution. The complete solution or complete integral of partial differential equation, the given partial differential equation, is expressed as f of u comma v is equals to 0, or u is equals to f of v, or v is equals to f of u. In any way you can express. Here I am taking f of u comma v is equals to 0. That is f of, our u is x cube by 3 minus y cube by 3. X cube minus y cube by 3 or V is x square minus z square by 2 is equals to 0. Okay, so this is the example for fraction method. Here, the two solutions are possible to obtain from the by considering fraction, any of the two fractions from the subsidiary equations. Now we will look into another example. Here, solve mz minus ny into dou z by dou x plus nx minus lz into dou z by dou y is equals to ly minus mx. Now observe, is it in the form of Lagrange's linear or not? So here, as we know that P is the standard notation for dou z by dou x, Q is the standard notation for dou z by dou y. So it is in the form of mz minus ny into P plus nx minus lz into Q is equals to ly minus mx. Here observe, it is in the form of pp plus qq is equals to r, exactly in this form. So it is called the Lagrange's linear partial differential equation. So we can find the subsidiary equations. Write the subsidiary equations. Dx by p, that is mz minus ny is equals to dy by nx minus lz is equals to dz by ly minus mx. Observe all the fractions. If we take any two fractions in this, any possibility, 1 and 2, 2 and 3, or 3 and 1, any possibility. Not even one possibility, we can't even express the two equations and the two variables. We can't even express. It's not possible to find a single solution from the fraction method. We can't find it out. So what could you next? Next we go with the multipliers method. Now we need to choose a multipliers, some multipliers for dx, dy and dz. With that multipliers, the denominator becomes the 0. Like that we need to choose the multipliers. Here I am taking, consider the multipliers L, M and N as a multipliers. Just I am taking L dx plus M dy plus N dz, multiplying that same multiplies to the denominator also, L times of mz minus ny plus m times of nx minus lz plus n times of ly minus mx. Just simplified. L dx plus m dy plus n dz lmz minus lny plus mnx minus mlz plus nly minus nmx. So simplify this. All the near denominator becomes the 0. Then we will take it as L dx plus M dy plus N dz is equals to 0. Now here observe this, L, M, N are the constants. So we can easy to integrate each term. So directly integrate the equation on both sides. L dx plus integral of M dy plus integral of N dz is equals to 0. That's integral of 0. So then we can L into integral of 1 dx, that is Lx, and M into integral of 1 dy is y plus N integral of 1 dz is z is equals to integrating constant a. So let it be considered u is equals to lx plus my plus nz is equals to a. This is one equation. Now we need to find the one more equation as v is equals to b, either by fraction method or by the multipliers method. Here fraction method is not suitable, so we can consider another way of multipliers other than these LMN. If I am considering the multipliers as xyz, let us consider multipliers x, y and z, that is x dx plus y dy plus z dz by x times of plus y times of plus z times of now just simplify, we'll get it as x dx plus y dy plus z dz by the denominator is going to be 0. Then we will consider x dx plus y dy plus z dz is equals to 0. Then integrating on both sides. Why? Because here we need to observe one more point here. The multipliers are x, y and z. And here observe this equation also, x dx plus y dy plus z dz. Each term is we can able to find the integration. Otherwise we can't evaluate the solution. Okay, we can choose the multipliers. With that, the denominator becomes 0 and the numerator we will get, we are able to solve the integrations. In both the points we need to observe. In that way also, in that way we will consider the multipliers. Now integrating on both sides. Integrate, then you will get it as x dx plus y dy plus z dz is equals to integral of 0. Then x square by 2 plus y square by 2 plus z square by 2 is equals to integrating constant b. So let it be considered v is equals to x square plus y square plus z square by 2 is equals to b. So therefore the complete solution is f of u comma v is equals to 0. That is nothing but f of lx plus my plus nz comma x square plus y square plus z square by 2 is equals to 0. This is the solution for this equation. For some type of differential equations, one solution we may get by using a fraction method, and another solution is not possible using the fraction method. In such a case, you need to consider another way, that's a method of multipliers method. It means that one solution you may find by the fraction method, other solution you can find by using method of multipliers. Both you can use in the one solution, but we need to find out the two solutions as u is equals to a and v is equals to b, and then write the complete solution as f of u comma v is equals to 0. Thank you all. We will continue the lectures and in the next concepts, that's a non-linear equations, how to solve the non-linear partial differential equations in the next videos. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.